flybacks from the perspective of an analyst and a pilot. I have been an analyst in JEPPESEN company for almost 5 years, and I'm responsible for one of JEPPESEN products mainly aimed at customers of the American market. So these are airport qualification and familiarization charts. And privately, I'm a pilot and have a PPL license, and thanks to it, I can use and test some of JEPPESEN and Boeing products in the air. Okay, so let's get started. Okay, so agenda of this presentation. So during today's presentation, I would like to present a short story of JEPPESEN company, tell about nav data and how it is used. It will mention the electronic charts and the numbers that are related to them. And then I will briefly show you how aeronautical data processing works by our company. I will present you our customers without whom JEPPESEN could not exist. In the next part of the presentation, I will focus on EFB itself, and I will try to describe their division and talk about them based on Boeing and the JEPPESEN products. Because of the fact that I'm connected with aeronautical charts myself, I will mainly focus on applications that are strongly connected with them. So I will introduce you to the FliteDeck Pro X application in the first place. Then I will tell you in a few sentences about the Aviator application, and what is the last one to present, the ForeFlight Mobile application. And at the end of my presentation, I will mention how the EFB world related to the charts and aeronautical data can shape itself in the future. So, and also after the presentation itself, we will have 15 minutes for Q&A session. So if you want to ask me a question, I will be happy to answer it. Okay, so the first slide about the history of JEPPESEN. So if we want to talk about the navigation itself, without which aviation would not have the right to be, I have to mention about one person. So one of the pioneers of aviation, I mean, earlier be JEPPESEN. So that is the founder of JEPPESEN company. And Captain JEPPESEN was a pilot who was distributing mail between Utah and Salt Lake City. This road is located above the Rocky Mountains, where the volatility of weather condition is unpredictable. So within an hour, condition can change completely. And Captain JEPPESEN has set himself one goal: to survive. In order to meet this goal, he decided to mark all important navigation points or obstacles in his little black book. In the days off, he drew along this road to, for example, measure a field that could potentially be a safe landing area in case of some emergency situation. He talked to the field owners and asked for the phone number so that they could consult the weather condition that they were currently experiencing before our operations. He climbed the mountain peaks himself and estimated the height of obstacles. All of this data allowed him to create the first aeronautical charts in the mentioned little book. Later on, JEPPESEN noticed that his data could potentially be of interest to other aviators, and in 1934, he opened a JEPPESEN company, which I have the pleasure to work with. And that is why we speak of him as a pioneer of aviation and father of air navigation. And the development of aviation has also led to the development of navigation itself. So creation of radio navigation devices, such as VORs, created the possibility of creating more airways that were based on them. So devices such as ILS created the possibility of making safe landings when meteorological conditions are not favorable. Are the modern development of GNSS, thanks to which we are able to cross the airspace and aircraft capabilities much more efficiently. And during all of these changes, JEPPESEN as a company has also evolved and provided aviation data for its customers to this day. Okay, so in this slide, the history of the company from its foundation to the present day is presented in chronological order. So an interesting date is the year 2007, when the Polish company SIMAP was acquired by JEPPESEN. And since that time, the Polish division of the company began to exert influence, employing over 600 people. And I have allowed myself to bold events that are closely related to the EFB. So it's 2002, when JEPPESEN presented its first EFB. It was the first step towards the reduction of paper documents on board. The next date is 2013, when a product called Mobile FliteDeck was presented to the world. And the last important date from the perspective of EFB solutions is 2017, when the cooperation with ForeFlight company was established, and electronic JEPPESEN charts could be displayed in the ForeFlight Mobile applications. Okay, so now data. So where is it used and what this exactly is? So nav data, as shown in the slide, is an aeronautical database that fits avionics or mobile devices for navigation. So they increase the efficiency of operation and above all ensure the safety. It was created in ARINC 44 standard in cooperation with avionics producers, stabilized in use in the 70s, and the first commercial test flight using nav data took place in 1973. The defining of errors and the introduction of manual and operation standard for use took place in 1975. Whereas the first full in FMS in commercial aircraft was started in 1983 in Boeing 737-300. So nowadays, nav data is used on many places. So also we use it on the ground during preparing for the flight, while planning it, navigating it, or performing the landing activities. Our data is used by pilot from GE to commercial aviation. We have the largest navigation database as a company providing the above navigation data. We have more than 18,600 airports around the world and 2.6 million records and the lowest alert rate from the navigation data providers. Okay, and maybe something about the electronic charts. So our second major product in our portfolio. So this is a digital version of JEPPESEN airway manual. So it's a paper airway charts. From en-route maps to approach charts, they can be displayed on OEM devices, or on portable devices like FliteDeck Pro X. They are the answer to market demand and pilots' needs. So thanks to them, pilots do not have to carry paper charts with them on a board. So they are the geo-reference, which means that if we have the right application, we are able to track our position based on the procedure we fly. What's more, pilots can easily update their databases and be sure that these charts are consistent with the appropriate IRAC calendar. And what do you get using JEPPESEN electronic charts? So one standardized data structure. So no matter in which country the pilots perform operation, the data provided by JEPPESEN will be the same. If they are looking for frequency information, they will be always find in the right place on the chart. So it doesn't matter in which country they will perform operations. Map updates take place every 14 days. So to ensure that the data will always be up to date and consistent with what the AIP of a particular country shows. Okay, and on the next two slides, I would like to show you quite interesting images which show our history related to the paper charts. So the first, so tracing paper days. So this slide show how map production used to look like in the period before computers and programs used for electronic drawing of maps. Tracing paper were used. So when you put the appropriate layers on top of each other, you used a specific chart, which then went into productions. And the second is how we printed charts. So these photos show our real printers and the process of map printed that took place in Neu-Isenburg. Most of JEPPESEN history is connected with printed charts, but since 2010, we have started the process of transformation. I mean the process of introduction to the first EFB, which result in starting to reduce the amount of paper on a board. In the strong ground, one iPad is able to replace a bag weighing over 30 kilograms. This, contrary to appearance, also increase efficiency as a result of weight reduction and fuel reduction. And for the example, at the German office, the last charts were printed in 2015, and currently we don't have our printers. We collaborate with one of our vendors from Phoenix, and he's responsible for printing our charts. And historically, in 2017, in our portfolio, we had about 150,000 charts and more than 5 million unique documents, pages, and a key amount of about 475 million printed pages per year. At its peak, in 2000, the German office alone printed 240 million sheets. Okay, the next slide is about the seat start to scale. So our seat start to scale, so standard instrument departure and start on terminal arrival charts are a very good example of data transformation and development. So the development of this application that are used for displaying aeronautical charts has resulted in the development of the charts themselves as well. So seat start charts were a long time a problem. Due to the size of procedures, these maps had no scale. Additionally, they did not present the area in the way required by the customers. So in 2016, JEPPESEN began the process of changing this fact, and gradually each map in our database was modified to new specifications, which also include scale, terrain, contours, or larger water bodies. So more than 12,500 charts have been modified for 850 airports. So this data increases flight safety as it provides more data. So, and the georeference of the maps made it possible to display them on a scale in EFBs. And this picture shows an example of start procedure for the airport in Gdańsk. On the left is the procedure from the Polish Air Navigation Services Agency, so PANSA. And on the right is a live example, which is a star map adapted in ForeFlight Mobile applications. Okay, aeronautical data, how does it work? So in this part, I would like to show you in a nutshell how the process of navigation data processing looks in a JEPPESEN. So in the first step, we get the sources from our providers. So one of such providers is, for example, PANSA. This source is called EIP. As a JEPPESEN, we cooperate with 246 providers from 195 countries. So as you can guess, such a number of countries will create a problem. So one of them is the language, and the dominant language in aviation is English. So most of the sources, like from PANSA, are in the native language, Poland in our example, and English. However, there are countries which provide the source only the native language. We are talking here about 24 different languages, and these countries are, for example, Brazil with Portuguese or France with French. We have analysts in our ranks who use these languages and process this data to make it readable to everyone. And aeronautical data are processed in an IRAC cycle, which is 28 days. And the system was created by ICAO in order to keep the data transparent and consistent by all members. So in JEPPESEN, on average, in the cycle, we process over 47,000 data. Processing of this data is mainly done by analysts who are responsible for specific assets. We create charts which supply the airway manual, and coding data which supply nav data. As a curiosity, this slide shows that annually we have about 1,500 source anomalies. These are various kinds of anomalies that we have to confirm with the provider to make sure that the data will be released are in 100% compatibility. Okay, so next slide. Becoming database. So these data are then proceed. Charts are properly printed and sent to the customer, and they coded data are presented in ARINC 44 format, so they can be uploaded to the aircraft's FMS. We are talking about a huge number of data packages which are packed under a specific customer and delivered to him. And database distribution. So, and how we distribute this data. So this is shown in the summary of this diagram. We can divide the data into those that supply the aircraft avionics. And here we can mention about JEPPESEN distribution manager, Fly Garmin, or IMDS data manager when we have a Honeywell avionics. On the other hand, we have the data which support mobile applications like FliteDeck Pro, ForeFlight, Garmin, or Avidyne. And customers. So I would like to mention the customers of JEPPESEN, without whom the company could not exist. Here are examples of airlines that have trusted us and trusted us with the safety of the passengers. And if it comes to the number, we serve over 650 airlines from all over the world. We have trained over 48,000 pilots, and every day we get 58,000 flight plans, 240,000 weather information briefs, or we manage more than 250,000 of logs daily. And the most important figure is the number of pilots who use JEPPESEN data, and there are about 1 million worldwide. So huge number. Okay, and now I would like to talk about EFB and aviation. So electronic flybacks are application or devices that help pilots or loggers to perform air operations safely. Depending on the type and purpose, they can be used to make calculations, store documentation, display weather information, or serve in lieu of paper maps. And the slide below shows the part of EFB that is produced by JEPPESEN and Boeing. In the upper left corner is shown the OEM Boeing EFB. The beginnings of this device data back to 2002, when it started to be used in the Boeing 777 for KLM Royal Dutch Airlines. The initial EFB installed in the cockpit of the aircraft had 4 benefits. So reduced fuel and maintenance cost to more precise calculations, improved safety during operation at the airport, like taxiing the aircraft. I mean here AMDB and aircraft positioning using a GPS system. The possibility of displaying images from cameras mounted on the plane's deck has increased the safety of the operation and minimized the risk of hijacking the plane. And the last benefit, and one of the most important, was replacing paper charts with electronic charts. And for example, Boeing 777, during one flight, pilots had about 35 kilograms of documentation, such as maps, minimum equipment list, or operational manuals. On the right, we have the Boeing onboard performance tool used to calculate the performance of an aircraft. In real time, we can perform mass and balance, takeoff, or landing calculations. The benefits of this application are the reduction of engine maintenance cost because we are able to use the full capabilities of the airport, such as the length of the runway when calculating the speed of rotation, when reducing the starting power of the engine, or the full use of payload aircraft through accurate mass and balance calculation. Thanks to the use of JEPPESEN's database of high quality obstacles, we have one of the best applications to calculate. It can be used in Boeing EFB and planes like 777 and 787 Dreamliner, as well as on our portable devices. Okay, I would like to mention the other 3 applications that are shown on the slide separately. This will be the FliteDeck Pro X, Aviator, and ForeFlight Mobile. Okay, so now something about classification of EFB. Okay, in the previous slide, I mentioned what EFB is and showed examples of it, which Boeing and JEPPESEN provide. On the next 2 slides, I'm going to present the division of EFB in a nutshell. So the EFB can be divided up for hardware and software. The division into hardware is shown here. We currently divide them into portable or installed. Before 2013 in Europe and 2017, I guess, in USA under FAA, it was common to use a division in class 1st, 2nd, and 3rd. Portable devices can be those that are not permanently installed in an aircraft and are not OEM. They can be connected during the flight to the aircraft through a charger, but a circuit breaker is required. And for example, we are talking about the FliteDeck Pro, Aviator, ForeFlight Mobile, Garmin Pilot, SkyDemon, and others. And the second type of devices is classified as installed. And here we can mention, they really mentioned Boeing EFB as an example. So this is a device that is an internal part of the aircraft. Okay, and software classification. So the second division concerns software. We'll be talking about two types here. So type A, concern devices or applications used to store documentation. And they have no major impact in a dangerous situation like a failure. These documents are, for example, FARs or noise abatement procedures. And type B devices are devices that have an impact on flight safety. So here we talk about application responsible for displaying aeronautical charts, checklists, performance data, and others. Okay, and share on the top. So I will start to talk and present you three of our major products from JEPPESEN Boeing. So I will start from FliteDeck Pro X. So the JEPPESEN FliteDeck Pro X is one of the applications from the FliteDeck family, addressed mainly to commercial, business, or military aviation. The application used on iPads allows pilots to perform safe flight operation in digital form. You will find terminal charts, en route charts, weather information, NOTAMs, navigation plan, and other features. Flight and route information. So the position on the plane can be retrieved by connecting the application with the aircraft interface device, for example, connected to aircraft system. It is also possible to obtain the plane's position from the built-in GPS receiver. In most cases, the flight plan is downloaded from the operator. So the flight plan is loaded by the crew, and it's possible to share it between the crew. We also have the possibility to create a flight plan manually. We can modify the points or airways that we want to use. The picture on the left shows the created flight plan from New York to LA with information about which points and airways we will be flying. After adding the airport or airport of takeoff and landing, we'll be able to load specific terminals charts like SEAL or STAR. The figure on the right shows the feature of route information. We have the possibility to screen the whole route of the flight. Specific points and legs with the data where all the most important information such as the airspaces that we cross, the frequency on which we should conduct the corresponding ATC. Both photos on the en route map show the road visually, and additionally the radar layer is turned on. So we are able to check the weather radar visually, showing clouds, icing, turbulence with division into flight level. This increases the safety of operation, and when planning a flight, pilots are able to estimate the weather conditions on the road and correct them early enough. Okay, airport data. In the airport data, the application will display substate information such as aerodrome reference point or aerodrome elevation. We are able to quickly obtain information such as frequency, NOTAMs, runways information with the characteristic terminal charts, weather data such as METAR, TAFs, or DIATs if available at the airport. From the decoded weather conditions, the application is able to visually show which category of conditions are in the airport. So in our case, the conditions at the airport in Gdańsk, so Echo Papa Golf Delta, were VFR. On the en route charts, we have the opportunity to choose high and low airway structures. So this allows us to display the appropriate airways and navigation points suitable for our flight. Okay, next slide. So airport and cruise information. So this slide shows three photos. The first on the left shows further airport information, more precisely the NOTAMs that are related to the airport are shown. The second central frequency and the photo on the right shows the cruise information. So the applications is able to display information about a specific space through which we'll fly, um, giving information such as separation or ICAO compliant space type. Okay, and the next slide about terminal charts and AAM. So this slide shows the most important features of this application, display of terminal charts and AM. And thanks to this application, we are able to replace completely paper version of charts. We have quick access to them, and in case of sudden change of departure clearance, we can quickly choose a new departure procedure. Uh, the maps or charts are geo-reference, so in case of FAA, we are able to display the position of the aircraft in the procedure parentheses at any phase of the flight. This increased situational awareness of the pilots and the safety of operations. So here you can find approach maps, seat star, reference maps, company charts, or airport maps as shown in the picture. The middle and the right picture shows AAM or airport moving map, a feature that greatly increased the safety of operation while the plane is moving around the airport. And these are charts or maps with these are maps, okay, with much greater accuracy than the airport diagram. We are in a very quick way to get information such as the full characteristic of the runway, get information from the stands, the road taxi when we get a clearance from the airport, or a new feature already loved by pilots, so low vis condition depiction. In the case when the RVR, so runway visual range at the airport, is low and start to apply LVP, so low visibility procedures, the application is able to display the right taxiways that allow us to safely taxi to the right stand. Okay, airport smart nodes. So airport smart nodes is a project that is being developed mainly in JEPPESEN's Gdańsk office. It aims at creating a database with different kinds of nodes about the airport and use on AM maps. This information is, for example, whether a given taxiway can be followed by a particular type of aircraft. The pilot will be able to, for example, after selecting a particular taxiway, click on it and to get the nodes that apply to it. This will simplify the pilot's work in ground operation, will be a step to reduce the amount of information on the airport diagram or briefing pages, and above all, increase the safety of operations. Okay, Aviator. So JEPPESEN Aviator is a product designed mainly for commercial aviation. It's an application containing functionalities of other JEPPESEN products. In one place, the remote control has access to all the necessary functions, allowing for safe and efficient operation. It consists of several models like dashboard, briefing, navlog, documents, tools. Customers have the possibility to customize other products they use, such as FliteDeck Pro, or on-board performance tool to Aviator, and they can have access to these applications while using the application itself. Okay, the slide shows pictures from various Aviator models. So on the left, navlog with a weather layer. In the middle, there is a main dashboard with data. Heads from the top looking like flight number, aircraft registration marks, sorry for that, takeoff and destination airport over time, weather data of airports, terminal charts or documentations. On the right side, an example of one of the functionalities, which is fuel analysis. So pilots during the flight are able to manually add correction and the turning points at the current amount of fuel. Okay, and now we talk about the ForeFlight Mobile. So ForeFlight Mobile is an aviation application for iOS system, which is used to flying mainly in general and business aviation. The application has a number of functionalities, and with its use, we are fully engaged in all activities before, during, and after the flight. From planning and mass and balance to navigation and analysis after the flight. In 2007, the company started producing the first EFBs for the American market. In 2018, it entered the European market. In 2017, also, the cooperation with JEPPESEN took place. And in 2019, it was acquired by Boeing. This is the main application used by pilots in the USA market. So it's becoming increasingly popular in Europe. Its greatest advantage is its versatility because it can be used both in IFR and VFR operations. Many of the elements from JEPPESEN nav data are used in this application, which gives certainty of quality and accuracy of all data. I personally use it for my flights, and a number or features significantly improve my safety in the air. Okay, so something about georeference JEPPESEN charts. So as I mentioned earlier, in 2017, there was a collaboration between ForeFlight and JEPPESEN. It was a moment awaited by the aviation community. It gives pilots the opportunity to use JEPPESEN charts in the application used for navigation. Pictures on the slide show such possibilities. The picture on the left shows the number of layers and functionalities we can turn on, from en route JEPPESEN charts, such as those displayed in the FliteDeck Pro family, to the possibility of applying weather radar or checking the price or fuel at a given airport. The rest of the photos show exactly the possibility of using electronic charts from the JEPPESEN portfolio. The georeference charts like approach, airport diagram, or seat star, we are able to put on the main body by adapting a specific procedure at the appropriate phase of the flight. And in order to increase the situational awareness, we can visually see our position in relation to the procedure. What is more, an interesting solution which is visible in the middle picture is the possibility of displaying a glide advisor. So if we give the parameters of our aircraft, the application is able to continuously show the current area where the aircraft is able to fly in case of an emergency and power loss situation. The wind correction is also taken into account here. If the pilot has an ADS-B transmitter, the application is able to display the planes in our area. It works in similar way like as a TICA system. So we get information about the plane size, the height, speed, and flight direction. In case the route of the plane crosses our area, we'll get an appropriate command. However, it can only serve as a situational awareness and not as an official source. An interesting option that also works very similar to the FliteDeck Pro is when the plane is running out after landing, and the speed is reduced. The approach procedure chart is automatically changed to the airport chart, and the pilot immediately sees how the airport looks like, including taxiway on stands. Okay, VFR layer. As I mentioned at the beginning, this application is a hybrid for EFR and VFR flying. So earlier slide showed us the use of JEPPESEN IFR terminal charts. In this picture, we use a typical VFR chart. This is exactly the popular sectional chart which is produced by DFS. ForeFlight gives the opportunity to add such layers for a specific country, and we have a typical aeronautical chart which is used more often by pilots flying under according with the visual flight rules. So this gives the opportunity to replace the paper with a digital charts. Synthetic vision and 3D view with weather layer. Um, One of the interesting features of ForeFlight is synthetic vision. It looks similar to elements of avionics of popular companies like Garmin. So we get all of information in one place. I mean here the high speed, altitude, vertical speed or bearings. Our track, okay, so it's mainly helpful in flying. For example, in the mountainous terrain where we can visually see the obstacles and our position in relation to them. It is shown in the picture on the left. The middle picture shows the approach to runway 29er at the airport in Gdańsk. The application shows our position in relation to the airport. So the photo of the right shows one of the innovations. It's the weather layer in 3D profile. So we can view our flight route and the application visually applies weather layers like turbulence and ice. But please note that these functions are only approximate and cannot be used as the main source of information. In addition, it's not certified avionics and the accuracy of the GPS receiver has its disadvantages. Weather layers. So this slide shows solutions that can be used to check the weather conditions. So we have different possibilities of applying layers, from checking where the thunderstorm cells are currently located to checking a pilot report about the weather, which are updated continuously, like in the case of the FliteDeck Pro. We can check these conditions depending on the flight level that we choose. And pop-ups. So ForeFlight is able to display as brief information depending on the phase of the flight or situation that is not foreseen. It can be concerned with an emergency situation or serve as a warning function. This slide contains some of them, like warning information, sync rate, or a warning about entering the runway from the length of the runway we have left. If you approach landing, you will be given information 1 nautical mile ahead of the runway threshold to confirm the runway name you want to land on. Information about the height that we are, for example, 500 feet above the ground level. We can also get information about the nearest QNH or transition altitude. Some of them resemble the operation of enhanced ground proximity warning system components. So as mentioned, the information about the sync rate. The information appears on the screen and is additionally presented verbally. This is to draw the pilot's attention. Okay, and airport data. So the last slide about ForeFlight Mobile concerns the airport data itself. So we are able to get all the necessary information to perform the flight operation, from the frequency to meters and TAFs to check the weather conditions. So from this level, we also have access to all the procedures that apply to a given airport or check the NOTAMs. What is more, pilots have the opportunity to add comments and remarks. They can share the observation about the airport, what to pay attention to, and what to expect. If a pilot wants to familiarize himself with the airport, has also access to AIP of the airport. And my thoughts on ForeFlight. So from my experience, the application perfectly fits its role. So we can use it for full flight planning, performance calculation, navigation. The functions informing about which runway we are approaching more than once can help us in the situation, when we perform operation at a new unknown airport. The application itself downloads the weather data, I mean the components of the wind, and recalculates them in a way that constantly gives us the real track with which we should fly. Thanks to this, we are able to take full advantage of the possibilities of plane, and flying is much more fun. And in the case of operation at the control airport in a quick way, we are able to find all the necessary information such as frequency, taxiways, or stands. We don't need to have on board AIP of specific airports because all of this information we'll find in this electronic flyback. Okay, and the future of electronic flybacks. So the future of application causing development and optimization, sorry for that, of aviation is certain. I will focus mainly on solutions related to charts and data that are related to them. So development of smarter data to enable more advanced data-driven features in popular displays. So this means creating data will be specifically specified for a particular type of aircraft. So this slide shows ILS procedure to runway 29er in Gdańsk. This is a standard chart that applies to all planes. On the right is shown so-called table with the landing minimums. It contains the data about the minimum heights and visibility that have to be respected in order for the plane to make a safe landing according to this procedure. The intelligent data could show the above in much simpler way. So the information that would appear, for example, minima, and would only relate to the specific aircraft on which the pilots are performing the above procedure. It would eliminate the remaining amount of unnecessary data from the pilot's perspective. For example, we want to land a Boeing 777 aircraft, and we would be interested in the data only for category Delta, so D, because this aircraft belongs to this category. This will increase the safety, of the flights. Pilots will have clear and precise data, which only concerns them, and the data does not apply to the mentioned aircraft would be omitted. So this is the future we are moving towards, and I will hope it will be soon. Okay, this is all what I have prepared to you. If there are any questions, I will try to answer them. And okay, so go ahead.
Okay, thank you so much, Kuba. I hope you can all hear me, and yes, hopefully you can see me now as well. Thank you, Kuba, for this wonderful presentation. Let's see if we have any questions, and I can see two at the moment. So first one, Kuba, what do you think about using the electronic flyback by pilots during training to obtain private pilot license or commercial pilot license?
Okay, so from my point of view, the electronic flight bags can be used as a support during training, while the basic techniques for calculating the road, checking the weather on the relevant pages, or the ability to submit a flight plan need to be learned without EFB support. So for example, the training to PPL license, the future pilot should learn how to navigate an aircraft, I don't know, using paper charts, plotters, mechanical calculators like the JEPPESEN E6B. But during further phases of the training, you can start using applications like ForeFlight Mobile or FliteDeck. Yeah, I think that the EFB are a good tool for the pilot after obtaining a basis license. So, for example, yeah, when we are preparing or when we are doing build hours in the air, it's a good way or the good, devices to to use because it's some kind of that will support you. Yeah.
Okay, thank you, Kuba. And one more question from Tom, Wonderful Tech. Related to the excellent question above, does JEPPESEN offer training, including recurring training, as new features are added on these EFB products to the client directly?
Okay, so I don't know exactly how it looks in JEPPESEN. Probably, maybe someone have more information about that. I can, I can check it and return with this information. but what I know, you can find, I don't know about the new features, but probably you will find if something, if something is at for example, for example, FliteDeck, then probably you'll find this in manual. And it's easy to find this manual. And for example, about the ForeFlight, what I know, the ForeFlight, if its company released something new, they always, include this information on the website. And also, it's very easy to find the movies on the official YouTube channel of this company. But I can try to get this information, and during the next session, I will try to answer with more details.
Okay, great. So just a reminder, guys, today at 3:30, we will have an open Q&A session. So Jakub, if you can find the answer, that would be great. If not, then we will have also opportunity to ask some questions tomorrow. I can see there is one more question. Is it legal to use EFB in light of paper maps during VFR flight in Polish airspace?
Okay, so very interesting questions. So preparing for this presentation, I ask myself this question. So for that is a very interesting question from my point of view. So can I legally have only FB on a board without a paper chart? So looking for confirmation, I found the answers to what it looks like in the USA very easily. The FAA has quite a bit of detail about for non-commercial pilots. In Europe, it's a bit more difficult. However, according to the Economics 6, Gen 135, you can use EFB in lieu of papers charts, but you have to have a backup. So maybe it would be different device which also has EFB or paper charts. However, during the ramp check, from what I've heard, we may encounter a situation where CAA employees are filling us because it will be hard to explain why we are using a mobile devices and not a paper chart. So yeah, as a curiosity, I can say that I asked this question on probably the largest aviation group in Poland with about 12,000 people on Facebook, strongly connected with aviation. And even there, it was very hard for me to get a clear answer. So you can see that, even people who have a different license do not fully know what it looks like legally.
Okay, thank you, Kuba. I can see there's one more question. Do you have to comply with a specific aeronautical standard for developing the software in use of EFB?
Ooh, interesting questions, but I don't actually know off the top of my head. But yeah, but I will try to get back to you later with this answer. Okay.
Okay, sure, no problem. Hopefully we'll hear from you at the Q&A session at the end. And I can see one more question. You mentioned that several features that ForeFlight has can also be found in FliteDeck Pro. Do you see collaboration between these two products?
From my point of view, yes. So yeah, personally, I see a lot of similarities. I don't know, what this look like from the side of development. However, as a normal user, I see many connections. So similar solution concerning, for example, weather layers. The display of information about the airports is very close. We know that the purpose of these two applications is different because JEPPESEN FliteDeck Pro X is an application mainly for displaying terminal, en route, or AM maps for commercial aviation or military. And ForeFlight contains more functionality because it's mainly used as a for general aviation pilots. So you will find there are solutions such as I don't know, performance of the aircrafts or checklist. So yeah, so in my opinion, it's a cool that these two applications are somehow similar to each other. Yeah, because it shows one common Boeing direction.
Okay, thank you.